All right, everyone. All right. So I'm open to anything you guys want to talk about when it comes to either assignment 6, assignment 7, if you've had a look at it yet, or any particular topic in the course that you want. So please fire away in the chat. There's only 7 or 6 of you guys right now, but 7 actually. But let's see what we can come up with for topics to discuss. While I still pick up some food out of my teeth because I just ate my lunch. Otherwise, I'll wait a couple minutes and then I'll see what you guys want to cover. While we're doing this, I'm going to just share my screen. Oh, there we go. We got a question. I'm in trouble putting print. Seeming another function that is not the main. That shouldn't be, well, it's printf, by the way. We can look at that in a second. I don't want you to share your code, but I can, if you can clarify where the issue is. It might be just like you don't have access to the variable that you thought you did. It could be any number of things. So it's kind of hard to nail that down. Let's see if we can, how do I say this? If you can come up with a nice way of sort of anonymizing or removing your solutions from the question. So if you can take whatever code you're having trouble with for the assignment and tweak it just so that you don't give away your answer to the assignment, that you can just put your code in there in the chat statement, and then we can look at it from there. Let me also do a, I'm going to share my screen here, and just because I'm going to open up a brand new project, hopefully. Not David Stuff's Carlton. BIT1400, fall 2020, and class code. Oh, I don't want that, actually. Sync A6, let's say. All right, and let's also see if you have any other additional questions, because I'm more than happy to go over how the printf statement was working, but if you can give a bit more background where it's going off the rails, that would be greatly appreciated. Oh, we got something at some point in time when, or it's just not going to let me do that. Okay. Oh, there we go. That's a classic for taking input. So for assignment 6, you shouldn't have to actually take input from the user. Just to be very clear about this, in case that's weight off your mind, you can test, you can get information from the user, but really, if you're testing to see if your code is working correctly, so for example, if you're, well, the calculating your average, right? The average of your top 8 assignments out of 10. That's actually the reason for that question. It was originally part of a bigger assignment question, which terrified a lot of students a bit later on in the term, where it was, let's calculate what your final average, how do you get your final average? Because, we're dropping a certain number of questions. Oh, great. Print f the, okay, return 0. It should be, okay, let's just take that and see what and run with it. But that shouldn't cause any problems at all, what you just gave me. Let's have a look at it. All right. I'm going to add a new item and A6 test code. Okay. every time. Certain IDs automatically wrap it around for you. So in case you're wondering what that is. Okay, so I'm going to call this new function. Let's plop it up here. Okay. And we're going to call replace. I'm going to need to pass in an array, a number of character. Okay, so great. So let's make character array text, and let's do this just in case you don't. Character array is equal to that, by the way, is a constant character array. The constant is referring to, it's a pointer to a constant characters. Let me see here. I always flick those around. It's a terrible syntax for this because it's so easy to mess it up in your head. If I put the constant after the pointer, it's a character pointer that is constant, so you can't change the pointer. This is, it's a character, it's a constant character. This thing is pointing to a constant character. There you go. Every time. I have a lecture on that later on. So this is pointing to a constant character, as in I'm not allowed to change that H. It is pointing to that H. It also happens to also be a pointer that I cannot change the pointer to, but that's neither here nor there. I'm not allowed to change that H. That's what that constant here is actually referring to. I'm going to also chars equal to strlen of my text. I'm just going to get the length of that thing. I need to figure out what string length is, and since I have the memory of a goldfish, I'm just going to actually, I should be able to just grab that. The printf should also give me something. Oh, come on. Include, it shouldn't be iostream, but it's iostream would give it to me, but that's not the best library to use, but iostream will do it. iostream is going to give me more stuff than I need. That's the reason I didn't want to use it, but fine. Okay, and what other things does character, or does replace need? The old character and the new character. Oh, this is a nice one. This wasn't the thing I asked you to do. This is from a previous assignment, right? Or from last term. So I love it as a question. That's why I gave it last year. We have a character to replace it by and with. Okay, so my text, that's the name of my array. Chars is the size of the string that I'm putting in there. I'm going to replace the old character is going to be L. Notice it's single quotes, not double quotes, and I'm going to replace it with an F. This is actually not going to do anything, but I'll actually fix that up in a second. And I'm going to make this, well, let's just make it a character pointer. Hopefully that's going to not barf on me. And I'll cast this one. Okay. Should compile. One build, one successful. Okay. And let's, we'll return from there. That's fine. And this thing is not going to do anything that I think it's supposed to do. It's just printing off the. It will print, it's only going to print off the. And if I called it multiple times, let's call it a couple more times. Okay. What's it going to do? It's going to output the in a row. Not on a new line each time, just the. The reason it's going to do that is because there is no new line on this thing. If I wanted it to be on a new line each time, I'd put a /n, but let's run this and see make sure that works. Okay, all right. So why I'm wondering where the problem was in the original code, because that's not seeming to be causing any kind of problems. Can it be printed without the function being called in the main? No, it will not. So that is a great question, or a great point of clarification. Code doesn't work by accident, and so a lot of people, once you get the mental model down, it's like, oh, of course. It takes a long time for everybody, actually, I should say. So what happens here? How does my code actually work? I will start off with main. I'll go line by line, down main. When I'm done my main, I'm done. That's it. There's nothing else. That's what your code is doing. It starts off in main, it ends in main. That's everything. If I call a function in main, I will jump up to that other function, do some stuff, go back down to main and do the rest of my stuff. But you essentially have one function, the main function, which starts and ends everything. It is one function to rule them all. And so if I don't call these other functions, they're not being tested. I can write them all I want. The code is there. They're just dead code. It's not being used. It's that's a bad metaphor, but me buying a car and not driving it, right? It's until I actually go to that function, I'm not using it. And so if I do not call replace here, you're not going to get a printf statement at all. It's fine. It'll compile. It just won't output anything. It doesn't go, it'll compile from the very top of the file downwards, but it will execute. My code executes from main. Every single language does this. As far as I know, every single language will do this. Yeah, there's a couple weird languages where they don't have a main, but pretty much every language that in industry that you're ever going to use does this. You have some starting point. It calls these other functions. So you can have as many functions as you want, but my main method is the start and end of my entire program. So when I get to replace, it'll jump up here, do these lines, jump back down, then do the next line, and then get out. So hopefully that. So is there any other problems that you had with printf? We can also do an interesting thing with print. If we don't want to do replace, we could do some other interesting stuff. But I just want to make sure you're feeling comfortable with the printf. The printf doesn't seem to be a problem in there. It was probably just a syntax error somewhere in your code, or you didn't call the function itself. If it's not in main, it can be in another function. You just have to call that other function. I have a start and an end to my program, and it is main. But most of my code is outside of main. Most of my code is somewhere else, but main calls it. So if you want to test your code, for example, if I want to test replace, let's test replace here, and let's actually do some code for it. So what would I want to do? I might want to make a couple examples. And I'm just going to leave that as hello world, and let's call that test 2, 3. It's text, but 3, and I'll make 4 here, and I'm just going to have a whole bunch of different test cases I wanted to have in here. And let's leave it at that one as well. Okay, I am going to call replace. I'm going to have a test. In the other cases, I'm going to use this thing directly. Okay, so let's test 4 other cases. Okay, so first case, I'm going to be replacing the character L with the character F. Everywhere I see an L, I replace it with an F. Let's replace, for the next one, I'm going to replace L with W. The next one, I'm going to replace capital L with capital F. And in this one, I want to replace the character value, the character 3. It is a character. I can represent numbers, I can represent tildes, and we're going to replace it with a tilde. And instead of the F, let's replace it with a tilde. Just to see, that's not going to work. Well, it's going to work, but let's do that one. And L with F. And I could try a couple other things as well. That's the point. If you're trying to figure out where things could go off the rails. I'm going to do one more test in here. And I'm going to try another case. I have no array. There are no characters in my array. Or I could just use quote, quote, if I wanted to as well. Let's do that one as well. And then one more. And I want to test this thing. I want to see what breaks. That's what my tests are for. So I could have some kind of printf statement in there, but just calling this function that many times and seeing what it spits out is useful, right? This is going to return, let's say, number of characters changed. So if nothing gets changed, I return 0. If one character gets changed, I return 1. If 3 characters get changed, I return 3. Okay. And case sensitive, replace characters in, that won't work at all. Ooh. Ooh. You guys caught me on this one. Okay, let's do this. I'm gonna have to make a buffer in here. Character a buff. You're probably wondering why. So let me just be clear here. This is a constant string. I'm not allowed to play with it. So if I try and change the variable, change some of the characters in this constant string, the compiler is going to yell at me. It's going to be a bad time. What I need is some kind of character array that's not like a constant string that I explicitly said, hey, by the way, you can't touch this thing. That's what this thing, when I use double quotes, it says, I'm going to give you an array, but you're not allowed to mess with it. So I'm going to make a buffer that's going to take in, let's say, 40 different elements. And everywhere I'm going to use this thing, I'm just going to have strcpy string copy. And this is my destination is a buff. And my source is my text. I'm just going to copy that a bunch of times. And I'm going to change what thing I'm using. A buff, and actually I want to pass in null here. That's fine. Both of those should be fine. I'm not going to be changing anything at all with this. Okay, and I need a buff is going to change. I need to see if string copy normally would say _s to say how many characters I can put in there. So let's put the _s in there actually, and let's just copy these again. All right, and I'm going to have the size of this thing that I'm copying, and it's going to be 40. I'm going to be lazy. Boop, boop. All right. And my text 2, my text 3, my text 4. Okay. And instead of my text, I'm going to use a buff everywhere. I'm going to use a buff everywhere. So now I can actually replace the characters in there. Nope, there you go. I cannot convert argument 1 from constant character to a constant character pointer. Oh, it's a constant character pointer. There you go. Remember I said it's something special when it comes to straight strings. So let's do this. Can I do the same thing as I did before? Yeah, let's do the same thing as I did before. And I'm going to replace this with this and put that down there. All right. All this, I haven't even written the code yet, by the way. I think my tests up, figure out what kind of edge cases I may have, what kind of weird crap can happen, right? I want to test a bunch of weird things, like what happens if I try and replace a character, but I only have capitals of that character, but I'm replacing a lowercase? Does it change anything? What if I have an empty string? What if I have a null, which is, it's pointing to nothing, right? There's no array at all. I'm just pointing to nothing. What happens? And hopefully this will be useful for the assignment as well. And if it's not, please ask me questions so you stop me in my tracks here. Okay, first things first, I want to see if array is actually reasonable. Okay, so if array is equal to null or array string length of array is equal to 0, return 0. This is my sanity check. If you give me this thing is pointing to nothing, that's what that character star thing is. It is pointing to the chunk of memory where the characters are. If it's pointing to nothing, it's like pointing straight up at the sky. It's pointing to nothing, null, which we'll look at a lot more in a lot more detail, then get the hell out. You're done. If it's pointing to something and it's an empty string, you're done. There's nothing to replace. Okay. If it's not that case, what do I want to do? I'm going to use a for loop for int I. See, I didn't actually need the number of characters technically, but let's do that anyways. So for each one, or let's also put one more in there, or numchars is equal to 0, is less than or equal to 0, just in case you gave me a negative number, get out. Okay. So for each one of these characters, I'm going to if array at position I is equal to old char, then array at position I is equal to new char. So I check to see if it's the thing I'm looking for. If it is, replace it. And then I need to have a count for how many of these things I have. So int replace count is equal to 0. Replace plus. Replace count is equal to replace count plus 1. Return replace count. That should do it. All this is going to do is walk down my array, moving things around. Notice other tests I should try. Try it with the number of characters the size of my array. So numchar is probably not the best name. Numchars tested. Let's just leave it at numchars. I'm assuming this is how long this string I'm going to be checking for is. Okay, so, and what I'm going to just do is walk down this array and see what I get. So what I might want to do afterwards is printf a buff. Actually, I want to do it differently. I want to have it on a new line each time. So that's probably from my text to, I should use that my text outside of this. %s to this. First, second, there you go. So I'm replacing I'm going from my text to the buffer. The buffer is being changed by calling this replace. And I'm just going to call that a bunch of times. Each time I've done, one more. Each time I do one of these things, I'm going to just find out what happened to my string. And I will just replace this one. This one's not going to be that useful because it's going from null. It's going from null to null. It's not going to change anything at all. I can't even do a printf on this one. So I can just, to make sure it works, I can see something like this would work, right? I'm going to conclude that this thing, if I pass it in a null, it's going to return 0. The kinds of tests you can throw at this thing. Okay, and then let's see one more. If I have one more in there, printf, there's that, and then one more printf. And it's going to go from there to, from there to there. All right. You might notice something weird when we do this last one. I just noticed it right now. Okay, and then I compile it. And so each time I call replace, I'm going to jump up here, do all this code, jump back down, do it again, jump back up, do it all over again. Notice the values for array, numchars, old char, new char are all going to change each and every time I do this function. All right, let's see if there was any chat messages. Wow. No more chat messages yet. Okay. So let's have a look at this and then we'll see what other question you have. Okay. It goes from hello world to hefo wolf. It goes from hello world to tilde, 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 tilde. Oh, it's out. I messed up something. That's not, this is what the text I'm actually replacing, right? I forgot to change the numbers here. So my printf goes from this. I have this. I have 2. I have 3. Right, I'm going 3. I'm going to go 4. I forgot to replace that. Let's look at it again. Okay, from to tilde, 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 tilde. Wait. Notice he has something weird going on here. This is the length here. I still have an L here. That's something weird. I want to look into that. It might not be doing quite enough characters in my replacing. Okay, it goes from hello world to hello world because nothing should have changed. If you look at my test case again, my test case for 3, I'm replacing the number 3 with tilde. The number 3 is not in hello world. So therefore it doesn't get replaced, the tilde doesn't get put in. I replace hello world capital, there should be a capital and lowercase one. There you go, that's this one here. The capital L is not the same as a lowercase l, so hello world does not change at all. There's no uppercase L, so nothing gets replaced. And then I change from an empty string to an empty string. I'm actually a little surprised by that last little bit. Oh, because I'm string copying the empty string onto that thing. Okay, that's fine. What I was concerned about is if I didn't have this line right here, if I didn't have that, I'd still have whatever was in there last time in my string buffer, and I get a weird message. So far it seems to be working generally well. There's something weird going on and I want to debug, why do I have an L here? So let's actually count the number of characters. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. There's 12 characters. Okay, number of characters that I'm passing in here, it may not be 12. Let's see what happens here. Okay, so here is that second call. I copy my text 2 over to buffer. I am then going to replace, it's not numchars. That's the problem. strlen of my text 2. You can, and you're looking for what could be causing the problem. This had to have the number of characters I was going to be the number of characters in the string. If I'm using the original thing, hello world is a shorter piece of text than the other number, the other string I was looking at later. That's why I didn't do all the characters. I stopped when I got to 10 characters, which is, or presuming the length of hello world. Okay. Okay, that's this, that's that. Replace, it doesn't matter how many characters I do here. So I could put 17 here, it shouldn't matter. That's fine. If the buffer is size, if this length, again, shouldn't matter, but I'm going to put a 0. Shouldn't matter. That's length 0, but it should still work. Let's have a look. And we should, unless something goes horribly wrong. Huh. My cout statement, my printf statements and my scanfs and stuff like that are doing weird things since 2400. I don't know what it is. It seems if it hangs on me, I just push like a space bar, give it focus, press the space bar, and everything goes. I have no idea. It's brand new. I'm assuming it's a bug in Visual Studio. Anyways, okay, that's working now. Hello world goes to hello world, hello world, hello world. Okay, everything seems to be working fine. And you can do other tests if you wanted to. The point is you think through your problem before you start coding. You doodle crap out on a piece of paper. Like, do I have an example of this? Not a great example because it's not actually everything. This is actually more my notes for you guys and what I'm going to organize things with. But Every single time I code anything, there's pads of paper around me. I'm doodling crap out. It's not this formalized pseudocode that we were doing earlier. It's playing with the numbers before you go in. If you do a math problem, you don't just barrel into a math proof. You play with some numbers to make sure it's actually true, to make sure you understand what the problem is actually asking you. That's what we're asking for here. Okay, let's see. Great, we have another chat question. Okay, I got an issue when putting an array value to I, array I, when doing I logic, I is equal to 0, etc. There's an error requires an array or pointer type for I. It should not require an array or pointer type for the value I. The index, you mean I, Ben? That should be an integer of some format. Or, yeah, it's normally it's a whole number of some format. It's either an unsigned integer. It's one of the elements of the set of integers, if you want. In for loops. Okay. So can you show me what your for loop top declaration of your for loop would look like then? Because I have a sneaky feeling I know what the problem is. I'll wait for that in a second because I have a guess. Call it a hunch. There you go. Oh, wow, that caused a problem. That's a little shocking. The reason it's a little shocking is I naturally assumed you left off the int in int I is equal to 0. If you left that off, because some people do, because they don't want to declare a new integer each and every time I make a new for loop, right? They make an int I at the very beginning of their function, and they keep using that same variable. But if I do that, and I forget to call int I make the variable, and I just use I, bad things happen. So when putting an array value of array I, so the question is then, are you trying to get the element at a position? Are you sure that array in your array I thing here is in if loop? Well, ifs are not loops, but good enough. I understand what your point is. The if condition for your inside of your loop, and you are checking to see. But can you show what's the type of data that you're looking for? Or so array in your case, what is it? How is it declared? Good. If loops with math operations. But do you mean like, so let's do an example here. Here's an if statement. I'm using arrays. I'm using an array called array. It takes in a particular element or index I, and I'm checking to see if that character is equal to old char. And then I'm accessing that individual I here. I'm a little nervous about asking for your code itself, but I think I might have to see what that actually looks like, if you can semi-anonymize it or something like that. If grades, okay. Okay, that should be fine. Grades is, I'm assuming grades is an array of, what you end up having is int star grades, right? It's an array of grades. Now my question is it because, okay, if it's int star grades, this right here is spooking me. Spook me for one reason though. What if you're outside of the bounds? So for assignment 6, you should not have to be doing a lot of moving around points and moving around variables. You can. That's originally how I wanted to do it. But shifting everything over by one actually ends up being complex for a lot of people. You can do it, right? You have a for loop, you just shift all the variables over by one. But your variable, you need to make sure that your I value I here is less than the last element in your array. This would have to be a valid index in your array. So if I have an array of size 4, and so I go from 4, and this ends up being 5, for example, it's going to cause a problem. If I have four, so let's put it a different way. 0, 1, 2, 3. If I go to element 4, I even have problems. So I need to make sure I am below 4 for both I and I plus 1. And that is a classic problem for most people, myself included. God knows how many times I've screwed that up. So the reason we were doing it the way we were, I was trying to make it easy. For the top n grades, the easiest thing would be to just stomp out the old grade and plop in some value called ignore value. The other options you could have done, I could have swapped the last element of my array, let's say of this one over here, and the element I'm looking at, the minimum element that I'm looking for. So you swap them, and then you say, by the way, I only have one less element in my array. That would have also worked. Right? There's a whole slew of different approaches you could take. They're all right. I was hoping that I was giving sort of an easier approach, but maybe that's not in fact the case. All we are doing with this thing here is we're trying to stomp out all the minimum values, the ones that we say is the minimum index in our array, and then ignoring those elements afterwards. So I don't know how many people need extra help with the assignment or not. So please speak up or forever hold your peace, because this is great, right? But Ben's approach is actually shifting all the elements down by 1. So he's removing the minimum element from the array and shifting everything else back down. It takes a lot of extra work to do that, right? Versus just stomping on a value. You have to shift everything over and then shift everything over again every single time I remove an element. That itself is order n, so it takes n operations on in average, and it might be n over 2, but a number of operations. And every time I remove an element, I have to shift move over n numbers each time. So you can definitely do it. That's fine. But you would still have to keep track of how many elements you have left afterwards. Again, still fine, still doable, workable solution. You just got to watch out for going beyond the realm. So if the last element that you're looking for, this is a nice little edge case, and then one of the things you would test. If the element the minimum element is actually at the very end of your array, you better make sure that it's not trying to shift things over onto it, because there's nothing to shift over. You're at the last element. There's nothing to move. So let me see if I can explain the approach. Let's make an array. 3, 2, 1. Okay, you'd find the last element, and then let's make a 4. 4. The idea is I'd find the minimum element, wipe it out, and then shift the 4 over into that position. And, maybe I'd still have a 4 over here. But I'd say now my array only has 3 elements in it. Okay, I've removed the lowest element. Now that my array has only 3 elements, I find the minimum element in an array of size 3. That value is 2. So I move this 4 over into the 2 position, and I leave off that 4. I leave the 4 element. But now my array only has 2 elements, and I can just rinse and repeat as I do that. The issue is going to be if I do 3, 2, 1, and then just leave it alone like this. I move over the smallest element. So this is my smallest element. I move the element to the right of me over. Wait, there's no element to the right of me. I got to make sure I don't try and move the element to the right of me. My stopping condition is actually I minus 1. I cannot move one step further than that. Otherwise, I'm going to be I'm going to be pulling data that's not in my array anymore. And so your conditions you have to be a little bit cutesy with your conditions. You got to think through, where's your stopping condition? What's going to cause it? The edge cases are like, what if the minimum index is the very last element? Do I shift anything over? No, you shouldn't shift anything over. So it's just how you play with the numbers, if you will. And the other option would be, let's do option 2 is, let's say 3, 2, 1, 4, and let's do 1, 2, 4. This is another option you could take. Okay, you find the minimum. There it is. I take that minimum and I swap it with the last element. 4, 1. There's just a bunch of numbers. Who cares? I didn't lose any data. There's no ordering effect. They're just all of your grades for the assignments. And then I pretend that I have an array of size 3. Fine. Then you'd have the same problem here with I find the minimum element, 2. I swap it with the minimum element, 2. Okay, nothing should change, but you just want to make sure you don't have a problem there. So nothing changes, and then I pretend I have an array of size 2. That would be another approach. There's a slew of these different approaches that you could take. You could have also sorted your array, which is a lot harder than it seems. You would sort your array and then pick off the last element with the first couple of elements, or only count from element 3 onwards. That would have also worked. There's a slew of different approaches. I made one suggestion because I was hoping it would be easier. Maybe I'm wrong, but that's what the plan was. Okay, can I answer additional questions? Anybody have any questions about structs, or people are not even looking at that yet? That would be assignment 7, by the way. So let's can I make a struct easily? Okay, let's do struct student, and then I have int ID, int GPA, and let's do something crazy. We're going to make a static array for each one of these things. Great. This is a struct named student, and I can make one of these things anytime I want. This is just the blueprint, by the way. This is for what A7 was going to be looking at. You're going to be making a struct. You're going to be dealing with that struct. In this case, it's going to be Chinese zodiac symbols, dates for Chinese zodiac symbols. We also have an enumerated data type, which is just a fancy term for I put a number on it that, peg is equal to, I think peg is actually equal to, is it 9? I always forget. Right. Each of these years, Chinese zodiac years are associated, or lunar years, lunar-based years, are based off around an animal. And we start with some animal, and we'll give it a number, and the next animal in the zodiac gets the number +1. The next animal after that, number +2, all the way down. So there should be, I believe, 12 zodiac symbols, right? So 12 different enumerated types. But let's deal with this in a second. So let's do this. Here's me making a student. Student David. I'm going to use lowercase to keep it consistent. All right. I have now made a brand new variable. This is me making my own type of variable. No one else has made it before. Brand new, custom, roll my own variable type, name student. I know, very original name. And I can access individual elements of this. So David.id. And I could set things 2, 3, 4, 5. Lab 6 on CU Learn. Okay, I've got to look in that in a second. Hopefully Janae has that under control. Okay. And I can make my GPA. I'm going to make myself give a 4.0 average because, I'm cocky. Okay, and let's do GPA and my name. Well, I need to set my name. I can't just give it a string. I'm not allowed to do this. Not allowed. Why? Because that is an array of characters that I have predefined, that I've set aside for myself. I can't just put another, and this is stored somewhere else. It's a chunk of memory as well. I can't just swap them back and forth. I need to copy the characters over. So the actual solution here is not to do this. So let's do this. Bad. Okay. Instead, what I want to do is something like this is CPY. Let's do a safe string copy. And then I want to do David.aName, and I'm going to have the size. It's going to be taking in a size of character in there. So the size of my array was 40, and then it's going to be David. And after all of this is said and done, what I'm going to do is I'm going to put a breakpoint in here. Oh, let's do size of, I'm getting ahead of myself because I'm interested in this sort of thing. What's the size of this? Student size is equal to this. The size of operation we're going to be seeing very, very soon when we do malloc. This is a little bit of an odd duck, and I realize I would like to talk about it. So, all right, building it, that's fine. Let's see what happens. Okay. By the way, if you didn't notice, I'm at this line here at the replace in this particular line of the replace. So I can actually tell exactly where I am in my code. Starting off the main, where I go down, when I go call this other function, when I call this, I can see the full stack of this function that calls this function, which calls this function, which calls this function. But let's have a look at what David looks like. Here it is. This is the David data structure that I made. It has an ID. It has a GPA, a 4. It has a name. And that name happens to be the string David. The name is a position in memory. That the name David is now in that array because I did string copy. Okay. And here's the interesting thing. At least I think it's interesting. Maybe you don't. Maybe you're asleep. I don't know. What's the size of my struct? It is, according to this, 30, right? But it's not 30. It's 30 in hex. So that is 3 times 16. Okay, what's the heck's going on here? What is that? How big is this thing? It's 28. This should be 4. This should be 4. If I sum all those up, it should be equal to this 30. So let's actually, let's get the actual value here. 48. Okay, so it's 40 plus 4 plus 4. So 40, 44, because each integer is 4 bytes. ID is an integer, 4 bytes. So in total, the entire struct is 48 bytes. A struct is the size of a struct is the size of all of the different things put in it. It is essentially a wrapper. You take a bunch of variables, squish them together, duct tape it up, and say, that's my struct. It is just all of those variables stuck together in one go. That's why it's 48 bytes in size, because it is the size of every single thing that is in the struct. What I can't do, unfortunately, is if I do the size of for a pointer, I will not get the size of the array. If I do the size of a pointer, bad stuff's going to happen. So let's try that right now, just because no one's asked any questions. And if you guys have any questions, I'm more than happy to answer your questions. So let's make a new array. Make a new array and a nums of size 3. Let's see what this does. So this is going to give me an array of 3 integers. What you'd expect is 4 times 3, 12 bytes, if it's the size of the array itself. It might be. That's why I always forget these things. So let's find out. Oh, I didn't save it. Darn it. Hold on. Okay, and there we go. Let's go down a couple steps. Enum size is equal to 12. Oh, that actually works for a static array. It actually works. I am actually surprised. I'm honestly surprised. The reason I'm honestly surprised is let's get the size of this array up here. And the reason why C is such a pain in the bum, we were saying the very first one is however big that character array is. Its size, we said the buffer size 40. So what I would expect to see, and maybe I'm wrong again, because I was wrong just now. So let's find out. What I would expect is, what one would expect to see is 40. The array that's being passed in here is size 40. We may not get that. I'm going to see if we get that. Nope. The array size 4. Not 40. We know the array I am actually using is size 40. I set it down when I made the array down here. Right here. Here's my array. And I call sizeof on this array, and instead of saying 40, it says 4. And the reason for that is I'm just pointing to the front of that array. And the size of the pointer itself is 4 bytes. Nothing to do with the array itself. And so what we end up getting is this really, really horrible workaround. The reason why we need this thing here, because unlike most other languages nowadays, you can't get the size of an array directly from the array in C or C++. You have to pass that into your function itself in order to make sure you know how big this thing is. Because otherwise, you just have a pointer to the very, very front of it. You don't know how big this thing is. Nothing is telling you how big this thing is unless it's a static array. So that is one of the things I saw a number of people try to use sizeof in their array. I'm like, no, it's not going to work. And that's the reason. Sizeof tells you how many bytes something is, but half the time when we're dealing with something, it's just something the thing pointing to a chunk of memory. And it's saying, what's the size of the thing the pointer, the thing that is doing the pointing. Okay, so here is a student. And if I wanted to access individual elements, just to remind you, I just put a dot and then say, which field do I want? If you've done things like, let me see, SQL or a number of other things, you'll see this kind of behavior as well. It's just this is the field dot, and then if anyone knows JavaScript, same thing, right? This is the name of my structure, and this is the field within my structure. And from there, what we're going to be doing with the Chinese zodiac is you're going to be using modular arithmetic to figure out what zodiac animal it is. And then you're going to be using modular arithmetic again to figure out how these, if you're compatible with somebody else. I like it as an assignment. And then after that, we're going to be looking a lot more at pointers and at memory and dynamic memory very, very soon. All right. What other questions do people have? I know that we're not covering A6 because people have not been asking about A6. So I'm more than happy to answer other A6 questions if you have any, if you're stuck on any particular part of it. Or if you want to ask questions about A7, I'm more than happy to answer. Because we have 19 participants and all of you are silent. And I tend to babble when people are silent and I'm just talking. Let's see what else we could do. Yeah, I think this week is actually strings, right? Or is it structs? It might be structs. So things like string copy, string length, that sort of thing. If we haven't covered them yet, we'll be covering them very soon. It's all blending together because I did a bunch of new videos for both this class and my other classes, and I'm working like 3 weeks ahead. So it's kind of, I forget what step you're necessarily on at any given time. Let's see here. There we go. Here is what we're doing right now. We're doing loops and arrays with miscellaneous functions. You're doing structs this week. You'll be doing flags very, very soon. And then next week, you'll be doing file IO, so reading from a file and dealing with strings. So you'll be seeing that strings length and all that kind of stuff very, very shortly. Right now, dealing with an array, let's see what we have here. When we're dealing with an array, we have things like we have a for loop. Oftentimes, we will just, all we're doing, I'm just always following the same pattern. I start at 0, how many steps I'm doing. So for example, let's say I'm trying to spit out the number of prime numbers between 5 and 10. Well, what I could do is do 10 minus 5, so 5 elements, start at position 0, and then add 5 to it. So, and then add 1 to it. So if I had, um, all right, I'm just going to comment most of the stuff out here. Here you go. Oh, I don't want to do that. Let's see. Let's use 10 and 5. So if I have, this is the range of values that I'm having there, and I would want to double check my work while I'm working on it. So my for loop can look like this. You could start your for loop at 5. That's fine. I could have started at 5, ended it at 10, and be done with it that way. So that would have been more than acceptable. I'm just a creature of habit, and I always start with 0 just because who I am. Or I could have started off at, here we're going to start at 5, and we're going to go to 10, but it has to be less than or equal to 10 to make sure I'm including that last number. Okay. And then I could say is prime, and then it's I plus 5, or whatever my minimum number is each time. So it goes 5, 6, 7, 8, right? And how many, what's a number of numbers is 5, right? 10 minus 5 is 5. So 0, 5, 6, 7, 8, 9. Oh, crap. I have one number, the number of numbers I'm dealing with. I do an example in my head before I say I'm done. I'm not sure I'm going to include everything, so I counted my hands, right? 0, 1, 2, 3, 4, or sorry, 5, 6, 7, 8, 9. I'm missing checking if 10 is a prime number. So I'll play with an example first. I could have also said less than or equal to. That's probably easier to deal with, right? And I just need to figure out how my for loops work. All right. No one's saying squat still. It's or they're saying it and this not saying anything. No problem. Okay. Oh wow. So nothing was been showing up. Sorry, guys. Assert test. Okay. Questions. Okay. Find how to find the index. Okay. Between R and R, there is. Oh, sorry about all this, guys. After all of this stuff that I say I wasn't seeing anything. It's because it wasn't popping up on my screen. Okay. Sir, I tried the sorting approach. Oh, jeez. Good luck to you, because the sorting approach is a pain in the ass. Between R and R, nothing. Style. That space means nothing. And so you'll have people with a space before, a space afterwards, space around both. I put it right next to the int because I need to know it's a pointer to an integer. That's how I view it. But there is no right or wrong answer. People will swear that they are right, but in fact, there is no right or wrong. There is styles that individual companies have, but the C standard does not force you one way or the other. When will we use strings? You'll be using them a lot. We just had to sort of avoid them until we're about to teach pointers. Strings are dangerous. A string, you mean the string class, by the way, Hasher? The string class, we're not touching at all this term. We're touching it in 2400 because it's an object. It's not actually in C, it's in C++. A C string, a character string, is just an array of characters with a 0 at the end. We'll be dealing with that next week. For A7, is there some reason when I try and put a variable under it and I only put one struct anything? Okay. Anything friend? You shouldn't be able to put a friend or anything like you cannot put okay. You cannot put another anything inside that, right? It's an infinite recursion. It would be an anything to an anything to an anything to an you can't stop it, right? When I'm making that struct, I have to make an instance of all the things inside of it. So if I put an anything inside of that anything struct, I will make another anything, which will make another anything, which will make it'll go off to infinity. So I can put a pointer to another anything. By the way, in the assignment, you do not have to do this at all. You just make two dates, two date structs, and then compare them. You don't put an actual pointer or reference to the other friend at the same time. It's the date, and you just pass both of those dates into your function. Okay. But yeah, you cannot put it's like saying, how do you define an integer? It's an integer. So how do you define an integer? It's an integer. It's an infinite recursion, right? You'll just keep on going. Okay. Okay. So there's no difference between this and this. There is no difference. Thank you very much. That's a great question. So you can also have a space between int and the r as well. So int space star space r would also be fine. How do I find the index? The index for the minimum, given code. I do believe it's given code. Correct me if I'm wrong, people. But right. So if I have if I'm trying to find the minimum index of something, you would just find the position in the array. It's the position in the array where that minimum is found. And when I'm doing that, I'm just keeping track of where I found the last minimum, the position where I found the last minimum. And I just return that. So, and we can definitely see an assert test. Okay. Oh, great. Thank you, Ahmed. That's a beautiful example of that. So the sum of 3 and 5, if my function was 3 and 5, the sum, if this sum function took in a 3 and a 5, I'm going to make sure it returns 8, right? I want some kind of test that if things go wrong, it blows up. So let me show you an example of where an assertion is really useful. Should be true, and therefore it doesn't give an error. Yeah, exactly. On A6, since the provided function min index returns the first index of the smallest element of the array, how do you set them to ignore values when the same, where there is the same multiple smallest elements in the array? You set it to ignore value, and then you call min index again. It won't find that minimum value anymore. It'll find the next one. If I need to replace 3 of them, I find the first one, replace it. Now there's 2 more. I replace it. I'm not going to move that finger. Replace this finger then, or replace it and replace it. I can just keep on removing them until I've removed enough of them. If I have 4 elements that are all the same value and they're all the minimum, I might only remove 3 of them. That last one's still around. As long as I keep on replacing with ignore values, it always replaces it. It's never going to find that 200. It's way too big. And so therefore you can just keep on calling min index, replacing it with ignore value, and call min index again, and I'll get a different number. All right. Primes in range, is it an int? Does it return an int? Primes in range, it's spitting out a bunch of print statements. I think it might return an int, as in it's saying how many prime numbers it finds, but I don't even remember what it actually said on this one. So if it does, fine. It might be a void function. You just have to look at the definition. It's not that what it's the return value is not the make or break of it. I wanted to give another assert here. So let me give you one more assert here. Is primes. Okay, there we go. Actually do it better. Here's a better place too. So let's comment out this thing. Here's a better place for an assert. Okay. I could say, let's do this. That's normally where an assert gets used. It's those, if something horrible is happening, you need to blow up now. If I'm outside of my array, for example, if my array has 10 elements and the position, the index I'm at is at position, so I have 10 elements in my array and I'm at position 11, blow up. In fact, that's what would have been really useful for that I+1 example that one of you guys gave me. That's where you would put it. I want to assert that I+1 is less than the size of my array. Because if it isn't, I need to blow up right away. That's where the problem is. Because it won't tell me that that's the problem. It won't tell me I'm pulling out things from outside of the array or something weird's happening. The assert gives me this like sanity check. That's what it's meant for. It's not meant for what we're doing. I'm overusing it, because what you should be using is something called a unit test, something that it's, we'd have to do a lot more work. The assertion is just saying this thing should be true for all times, for all circumstances, no matter what. If it's not true, blow up in my face. Because if it's not true, holy crap, right? It's the emergency measure, right? If this thing is if something went wrong, I need to know about that right away. That's what an assert's for. So it's things like, is my index greater than 0? Because if it's a negative value, holy crap, blow up in my face. If the index inside the array, the bounds of my array, if not, blow up, right? That's the kind of thing that your assertion should always normally be doing. If it's supposed to be a bunch of grades, is the grade I'm looking at not between 0 and 100? If it is not between 0 and 100, maybe blow up. If the value is a negative value, blow up. That's what an assertion's for. And it's just something that whatever this is in here, it should always be true. Number of characters is greater than or equal to 0. If it's not true, blow up. It's really useful, and that's actually what's being done right here. It's actually using an assert inside of this. If you try and copy more than 40 characters from here to here, so if this is more than 40 characters and it's trying to be copied over to here, it'll blow up in your face, because it goes, whoa, you're not allowed to have more than 40 characters. We're going to go beyond the size of the destination array. If I'm going to run out of bounds, I need to know right away. That's what an assert's for. All right. I actually have to pick up my kids now, guys. So, okay, let's see what other, by the way, very nice. And thank you, Wilmid, for the answers. Okay. Okay, minute X returns of, okay. Oh, we already did that one. All right. So thank you very much, guys. I'm sorry about not seeing your comments right away. You actually answered your own comments amazingly. So good work for all of you guys. Enjoy the rest of your day as well, and I'll see you guys very shortly. Please make sure post other questions if you have any. I'll be checking throughout the day today. Yes, the office hours are going to happen on Discord. Jenny's looking forward to them, and I'll be making sure I answer some questions as well tonight. Okay. All right. Thanks, everyone. And I will hopefully stop sharing. Okay. And I will talk to you guys later. Appreciate it.